Hello, exercise 12e. Look, connected rates of change is the posh title for this, and it basically involves a bit of more work on the chain rule. And very often they're quite wordy questions, so we just need to bear that in mind. And I suspect the reason why I've got this dopey picture of people blowing up balloons is because sometimes you might get asked a question about the rate at which a balloon's volume increases or something like this. It's a little starter for us. First of all, note it says that this is the chain rule. We saw this last lesson video when we were integrating parametrics, and dy by dx is dy by du by dx. We've got a different letter here, and you were just meant to fill them in, so see if you can fill them in. Hopefully you paused the video there. Hopefully it was fairly obvious, dy by dx. Now we've got a dy and a dx, we've got a dt down here, so therefore this has got to be dt. What have we got here? dv over dt. So dv over dt, we've got those. dr, that's got to cancel with r, because effectively then that cancels with that. That's basically all we're doing. That cancels with that, and you've got the same on that side. Well, dy by dx, dy by dz, dz, well, I need a dx obviously, because they will cancel and then it'll work. dy by, oh, we've got three here, dy by dt. And notice the first one and the last one is dy by dt. So this dA here has got to go up here, because then they cancel. And this here has got to say dc, because then they cancel. And it will still work. That's what we've got to be able to do. So anyway, here's an example of connected rates of change. I did say they were wordy. Water drips from a tap at a rate of 5 cubic centimeters per minute. So already I'm thinking water drips. This is the amount of volume probably. dV per minute. So dt equals 5. It is collected at a cylindrical glass with a base of radius 2. So this is my glass, presumably. So I've got r equals 2. What is the rate of increase? Now look, notice when as soon as I saw the word rate, I wrote something down. And I'm going to do it here as well. The rate of increase of the height, so dh, and when it is of its rate, it's dt. That's what they want me to find, dh by dt. What is the rate of increase of the height of the water in the glass? So I need dh by dt. You'll notice I can better use a chain rule, and I've got some information about the volume. So I'm going to write dh by dv, dv by dt. Notice the v's cancel. Now, do I know something about the volume of a cylinder? So, well, I know the volume of a cylinder formula. Volume equals, it's the area of the base, which is pi r squared, times the height. Now, luckily, I know what the radius is, otherwise I couldn't do it. I know the radius is 2. So 2 squared is 4, so it's 4 pi h. That's the volume. Now, I will need to find, for this question, dv by dh. Now, imagine I had y equals 4x, and I differentiate it. It would obviously be 4. Now, this is no different, really, apart from the letters in h. Well, it's the same as x, really. And I've got a nastier number, I've got 4 pi. But the same thing applies. When I differentiate that, I get 4 pi. The h just disappears. Notice, by the way, I don't want dv by dh. I want dh by dv. So that's 1 over 4 pi. And that's times by dv by dt. And dv by dt I've put up there. It's 5. So I don't know what that is, but it's obviously 5 over 4 pi. Type it in, I get 0.398. 0.398, and what is that? That is centimeters of that the water is rising per minute. This is a rate. This is the height change per minute. 0.48, so that whoever did this before me rounded to 2 dp rather than 3 significant figures, but that's fine. So what you'll notice there then is this use of the word rate. Wherever you see the word rate, you think about what it means. A block of ice is melted at a rate of 3 cubic millimeters. So there's my block of ice. Now when it's melting, that's the then look at the units as well. This tells you a lot. This is 3 cubic millimeters. That's a volume per minute. So dv by dt equals, well, technically minus 3 because it's going down. Assume it remains in the shape of a cube, which is a bit dodgy, but there you go. Find the rate at which the edge x is decreasing when x is 10. Find the rate at which the edge dx is decreasing, dx by dt. I want to find dx by dt. I find dx by dt by doing dx is on the top. Notice I've introduced a v here, so I'm going to do a dv by dt on the bottom. And in order to do that, then I'll need to know a formula for connecting v and x. And of course I do. The volume of this cube is x cubed times width times height, and therefore dv by dx is 3x squared. But I don't do that, I want dx dv, so it's 1 over 3x squared times by dv by dt, and that's minus 3 times by negative 3. They've said do this when x is 10. Okay then, so that's 1 over 3, x is 10, so that's 100 when I square it, times negative 3. I reckon that is minus 0.01 when you chuck that into your calculator. What's the units of this? This is centimetres per minute, or millimetres per minute. That's what the answer says. It's decreasing, I agree with that, because it says minus, at a rate of 0.01 millimetres per minute. Perfect. So this question says the area of a circular stain on the floor is increasing. First of all, it's circular, okay, make sure I know that. It's increasing at a rate. So whenever you see this word rate, as I said before, highlight what it means. It's the area, so that's it. I was like dA, I'm going to write. It's a rate, it's always dt. dA by dt is increasing at a rate of 10 square centimetres per second. Find the rate of increase of the radius. I want dr by dt, the rate of increase of the radius. So that's dr by dt, yes. And we'll just say that's dr by dA, dA by dt. You'll notice I introduced the letter of the thing that I've been told about. I better find a formula for an area of a circle. Well, the area of a circle is pi r squared. So dA by dr, bring the 2 down to the front, 2 pi r. You'll notice that's the interesting, the circumference formula for a circle, but there you go, that's another day. So if that's true, and it does it says find the rate of increase of the radius when the radius is 5. So when the radius is 5, this is 2 times pi times 5, or 10 pi. So let's chuck this into here. It's dr by dA. Now I found dA by dr is 10 pi, so dr by dA is 1 over 10 pi. I times it by dA by dt, which they told me was 10. That's easy enough. It's 1 over pi. No idea what 1 over pi is. 1 divided by pi, 0.318. What is that? It's a rate of increase of the radius. So that's centimetres per second. So what the answer says. 0.32. Yeah, there you go. And a large spherical snowball, so imagine a spherical snowball, is melting at a rate of 0.1. So again, you read that and notice the units is cubic meters. So this is dV by dt. This is a volume per hour, it would seem. A rate of is 0.1, and it's melting, so it's decreasing. I reckon that's minus 0.1. And find the rate of decrease of the radius. I want dr by dt. And again, you could say to yourself, well, introduce this letter they told me about. dr by dv, dv by dt. And that implies I need to know something to do with the volume and the radius. And luckily I've been told in this question, I knew it anyway, but I wonder how many of you did. The volume of a sphere is 4/3 pi r cubed. So if I want to find dv by dr, bring the 3 to the front and times by the 4/3, that actually gives me 4 pi r squared. Again, that's actually the surface area of a sphere formula, but again, save that for another day. Find the rate of decrease. Well, again, it says when the radius is 50. But it does say 50 centimetres. 50 centimetres. And of course the original question was all to do with cubic metre. So I think I might have to be a bit careful here. I'm going to say this is 0.5 metres. That's the easiest conversion to do. And that's probably going to save me when I'm doing this. So therefore dV by dr is 4 times pi times 0.5 squared, in metres of course. I might need to change it back again because they actually want the answer in centimetres. So it's 4 times pi times 0.5 squared, which I should have sussed that already, is pi. And therefore, notice that's dV by dr, I want dr by dV, so it's 1 over pi. And it's times by the dV by dt, which they told me, which is minus 0.1. So it's minus 0.1 times by 1 over pi. And I get negative 0.0318. Now, that's obviously in meters per hour, and it wants the answer for the rate of decrease in centimetres per hour. So if I times that by 100, I would get 3.18 centimetres per hour. Technically it's negative, but I would describe it in my wordy answer as a decrease. It's decreasing at a rate of 3. And they've said 3, they've said exactly 3. Actually, I reckon it was 3.18. I don't know. I think I'm right. I think I've got that right. So look, those are the questions. That's exercise 12e. Anyone who's keen, there's an additional exam question here which we might have a look at. I'm not sure. I've not even looked at it. I'm not going to do it now, but we might start the lesson with it next time. If anyone's keen, there it is. You can have a look at it to your heart's content. Best of luck.